Aaron Tuttle here for Ferguson Roof Systems. For 43 years, Ferguson Roof Systems has been protecting Oklahoma's homes and businesses with quality roofing services. Their goal was to be the most honest and dependable roofing company in the state, all while providing free services such as lifetime labor warranty and annual inspections. Well, mission accomplished with thousands of client testimonials, an A+ Better Business Bureau rating, and a 5-star rating on Google. Look, the weather gives you enough to worry about, so why worry about who to trust with your roof? Call Ferguson Roof Systems today or find out more at fergusonroofsystems.com.
All right, we are up and running, I believe. I think so. Yeah, I think everything looks good. Okay, it is, 9:39 on a Friday night, so thanks for joining me. You come to the right place. We're talking about the latest in the upcoming Super Bowl Sunday snowstorm. We'll see what happens with this thing. We'll see if I'm more excited, less excited, more confused, less confused. All that stuff. Ooh, it's a good one. It's a fun one. That's for sure. It is challenging. I will tell you that. A lot of moving parts on this guy. Give a few more seconds. Everybody kind of come in here so we don't have to repeat too many times. Choctaw's in the house. Nope, Christine, you're not LTTP. Good evening, Tammy. Mrs. Tuttle's in the house. Chickasha, Kingfisher, Stillwater checking in. Harris, Edmond, Tulsa, Owasso, Tonkawa. Some of you guys up in northern Oklahoma, I'm probably a little disappointed. Casey's already jumping at me with some stars. Thank you. Must be wanting some snow up there in Stillwater. Let's see, who else we got? A rain blizzard. That's right, Shelly. It's going to be a rain blizzard. Let's see, Rhonda's in the house from Geronimo. David, thank you for the stars. And Sean wants 13 inches of snow. Hey, if you're going to go all out, you might as well go big, right? So there you have it. Blanchard, Altus, Moore, Nuwala, you guys are all over the place. All right, good to see you here on a Friday night. Grab yourself a nice cold frosty beverage or a glass of wine or whatever suits your fancy. And we're going to dive into the data, see what's shaking and baking for our Sunday, and then I'm going to let you go so you can continue on with your Friday evening activities, just like myself. We're halfway through a movie. We're watching The Beekeeper with Jason Statham. I love that dude, and he always whispers in his movies. He's very soft-spoken, and he just kicks everybody's butt. I mean, how can you go wrong with that formula? But man, those dudes that rip off old people, or just anybody really, with a computer, that scam, and how the humans just get off on that, and they get all, they're it's like evil, just evil of evil. I'm like the dude, makes you just want to burn the place down. So don't spoil it for me. I don't know what the rest of the movie happens, but we're gonna get back to it here in a minute. All right, so let's get on with it, shall we? Let's see. Again, I posted a link in the comment section if you want to join the Facebook weather broadcast channel. I've got about 5,000 of you in there. It stopped at 5,000. I don't know if that's a cap or not. So if you can't get in, just try again later. I'm not sure what's going on with that. I did send a message to Facebook support, see if they'll help me out. But we'll see what happens with that. Otherwise, what I do is I use that channel to let you know when I go live. That way you don't miss anything. Jill, I see you on YouTube. Thank you very kindly. Appreciate that. It's very nice of you. See you guys checking in. There's Jim from Mustang. They want some snow over here on YouTube. They say, give it to me. Okay, so it's quiet right now, obviously, the calm before the storm. We're 54 degrees. It's a nice night out there. It's not too cold. And we've got some changes to talk about. We have a weak cold front coming in, and that's going to set the stage for a little bit of a cooler weekend than we've had this week. But we're kind of focused on tonight for what's going to happen with the snow and the rain. Now, if you watch me at noon, I showed this little graphic for you because I want you to visualize how frustrating this forecast is going to be. If you look at this little line right here, this is temperatures going up in the atmosphere, all up here to the cloud, down here at the surface. And this is our 0 degree line, 0 degrees Celsius right here. So this right here, also known as 32 degrees. If you're on the left of this line, you're below 0 degrees Celsius. In other words, you're below freezing, which means everything that falls out of this cloud is all snow, and lots of snow at that, all right? And you're getting tons of snow hitting the ground with, on this plot here, this graphic shows a 1 degree Celsius temperature. So around it's like 1.1. So right around 33 and a half, 34 degrees Fahrenheit. All right, so that's really a couple degrees above freezing technically. But because it's so cold, just a few hundred feet off the ground, our freezing line is right about here at the top of the buildings. The snow does not have a chance to melt before it finishes those last few hundred feet down to the surface, and so you do get accumulating snow. Now, what a difference that 1 degree can make, let me show you. So if tomorrow we have 1 degree as our warm column in the atmosphere here at the surface, is fine. Let's say we just go to 2 degrees Celsius. That's not a big change. That's only about 30, almost about 36 degrees, roughly, a little under. And what you're going to see is a change in this output that we showed earlier, which is you will notice that the snow that falls out from the sky, once it gets to the area right here around the city skyline, which is, like I said, a few hundred feet to about 1,000 feet, the snow will start to melt into raindrops. So once you get above 2 degrees Celsius, that ends up being the end result, which means you can go either from snow to rain just like that in 1 degree change. And so that's why this forecast is so difficult, because the model resolution is not that great to be able to tell you exactly who's going to get that 1 degree change. So we'll look at it tonight, and then we'll see what the latest data shows. The Weather Service that put out this graphic earlier, let's see, I think they put this out at 8 o'clock this evening before the new model data came in. This will be off the stuff from earlier this afternoon. They highlight this yellow line right here. Confidence is lower than normal. Yeah, this is a mess, man. This is a hot mess. Otherwise, they're still going for a good amount of snow probabilities out here into the I-40 corridor and the down southwest quadrant. So if you read my Facebook post today, they jive with what I had said earlier this afternoon. So we're kind of on the same page, and then coming through 44. But we'll see what the new runs have to show us. Timing on this for the snowfall transition over from rain to snow will happen quickly Sunday morning. So this is the timeline here. The Weather Service put this out, and it's actually pretty decent on the time. I can go with this. But what you do notice, noon, Oklahoma City, west side. So yeah, we could have snow in here as early as noon, otherwise later. Just depends on the exact track of the storm system. If you do look at amounts, this is where things are going to get really messy. All right, so right now the Weather Service is going to the highest snowfall amounts, kind of in this quadrant here of southwest Oklahoma. I don't really have a problem with that originally, but we're going to have some other hot spots in there. And these amounts, it's going to be so hard because there's going to be a lot more than this that falls from the sky, but it's just harder to measure because if it melts too fast. All right, here's a look at northeast Oklahoma. They're giving northeast Oklahoma just a dusting of snow. What's that say? Less than 1/10 of an inch of snow? How are you going to measure that? All right, Tulsa. So this is in jeopardy of having to be a big adjustment. I'll show you the date on that in a minute. Meanwhile, temperatures out there are for ground temperatures are into the upper 40s, low 50s, as we mentioned before. Okay, so the jet stream pattern, the upper levels of the atmosphere. Here's a look at the NAM model. Been using this one as my anchor because it usually does fairly well at tracking upper level lows. And there it is for Sunday evening, right down here in the southwestern tip of the state. So the difference I've noticed in this model is it has slowed down the track a little by little each run. Now, here by midnight, so really about a 6 hours difference in location. So at midnight, it now has a low kind of centered around Ardmore. Whereas in our data last night, I think even early this morning, it had the low centered around Ardmore around 6 and 7 o'clock in the evening. So that's a 6 hour delay for the storm system. So in other words, it's moving much slower, but it's still got the same similar track. Moves across eastern Oklahoma and into northwestern Arkansas by midday Monday. And of course, that takes all the snow out of it. Here's a close-up view of that. Just want to show you where it was coming from. So this is the center of the upper low. And remember, you want to be from the track of the low, you want to be on the north side of it. So what happens in these upper level lows, the favorable snow kind of comes in a comma head shape like this. So as the low kind of does maybe something like this, we'll just kind of just throw that out there as just an example, you would see the track of snow follow it like so. All right, so that's why the I-44 corridor is a favored track. I-40 out west, 44 down southwest, and even a little bit of 35. Don't get too far south, but that is why that is the favored zone for the snow. Now this is the NAM model. I just want to show you the position of some of the others, just kind of give you an idea. It's about 6 and 7 o'clock tomorrow evening. All right, so there's the UK Met. Matter of fact, let's do this. We'll make this easy for you. Let's put it on here. UK Met, the Canadian model. Let's see. It's a little more elongated, but similar. The RAP model is here. The NAM model here. Icon model here. GFS here. And European right there in the middle. Hey, so they're getting better at as far as the agreement on the position and the timing and the location, which is what we expected on a Friday. When you get within 48 hours, that's when the models really start to shine. All right, so now the question is the track, right? So let's just go to the midnight hour, and we'll see how they differ, if at all. So let's see this. So they started, they started right back in that area. Okay, so let's see here. We've got the track here from the NAM. UK Met's up here. Canadian is down here. Icon right here. GFS right here. And European right here with the GFS. How about that? Okay, so this is where they differ a little bit. And the problem is this is a big difference. So the progression is a little off. In other words, they're not in unison as far as the direct movement and where this thing is going to go. So what this means is if you track this, you got one solution that kind of goes like this, and you got another solution that basically goes like this. Now, there's a big difference what happens in your snow track. Obviously, remember the upper level low, the comma head I showed you on the back end of it? So if it goes down south, you get a lot less snow, and what it is more south. If it goes more north, it's more snow, and over kind of the I-44 corridor hits Tulsa and Oklahoma City and Lawton. So you're obviously rooting for the northern track for the body of Oklahoma for the best snow potential out there. If it's on this southern track, it's going to really limit amounts. But anyway, so that's the deviation still at this time frame once you get beyond the 24-hour window. So we're still having difficulties. All right, but let's just assume the NAM is right. And I showed you this earlier today. You will notice, remember that the circle here is where we're going to center for the center. This is at 700 millibars. The bright purples and reds where you get a lot of heavy precipitation. So in this particular case out here in western Oklahoma would be all snow. Here would be just rain, just a cold rain. So that's a noontime. As we go into the mid-afternoon, look how it expands into central Oklahoma to the east. So some of it's going to be a mixture of rain and snow. As we head into the evening hours, and man, if I put the highways on here, that's what it looks like. I-44, right? And then comes down here to Lawton, and then splits out west I-40. So hence the I-40 and I-44 corridor. Are you following me? You smell what I'm stepping in? That's in the evening hours. Midnight, it now starts to ship the heavy stuff up around Tulsa, northeastern Oklahoma, and on into the daybreak hours for Monday morning into southwestern Missouri, northwest Arkansas. A little leftover flurry activity there in the northern counties for Monday morning. All right, so that is where the best lift is, focused on the state, which is, knock on wood, jiving with the forecast for the last few days. Still has to happen, though, and that's the scary part. All right, so I'm going to show you the NAM model. Remember, this was, you have to have, in this pattern, remember how we started the broadcast with that little graphic? 1 to 2 degrees makes a big difference, right? Anything 2 over, forget about it. So here's the 1 degree, 0 to 1 in the green, and here's that little secondary line of 2. If it's over than 2, it's a cold rain. So we're going to start this at noon on Sunday, and we're going to outline where the snow is actually possible due to the warmest temperature in the atmosphere. All right, so it's something like this. So, okay, so that's through the first half of Sunday. Now that means by noontime and afternoon, technically, according to the NAM model, we should be too warm and a few layers of the surface up to melt that snow, or we should not get snow, which is contradictory to some of its other data that it's trying to spit out. It is torn to have a snow this early, but regardless, let's just leave it at that. Now we're going to go to the next, let's go to the next 3-hour window. All right, I'm going to have to keep moving this thing over. All right, and now we've kind of expanded this blue to kind of cover now Oklahoma City a little bit. All right, now we go to the midnight hour. I have to move this again. So now we've extended up the turnpike, knocking on the door to Tulsa. So there is the progression of the cold pool coming down and marching up the turnpike as the upper level low marches with it. So these, again, all temperatures around 1 to 2 degrees where you're going to have snow. Outside of this band, 4, 5, 6, 7 degrees Celsius, 5, 4, 3, 2, no snow. This will be rain. So it's just all rain. So that is how this progression works. It's a very thin area of dumpage potential with that snow, because that's where the cold air is. Now, this again assuming the NAM is 100%, knock on wood, right, no deviation. It's not wrong in any manner. asking a lot. All right, by the time we head to Sunday night and Monday morning, same idea kind of comes up here. So you get you get the gist. It's a very thin window. We're tracking the actual cold surface temperatures where it's at the cutoff, the threshold. Anything more than 2 degrees, forget it, it's rain. Anything less than that, you get the big wet snowflakes. Now, I will show, I'm going to back it up to Sunday evening. So I do want to show you something, how the models will differ so much. So this is the NAM. All right, so remember the dark, we'll just look at the darker green. That's zeros. That's a surefire bet, right? All right, let's just go with the Canadian. Look what happened. Where'd that big dark green go? It's got a little spot here almost, here and here, and otherwise in Texas. The wrap model, now the wrap is even colder than the NAM. I'm really pulling for the wrap because it's all in, and I mean all in. And it's got a larger area. It transitions snow over to Oklahoma City much earlier, like in the mid-morning hours. I mean, it is going all in. All right, the 3-kilometer NAM, it erases all the cold air. It says we're too warm all over across the entire state. Some of our high-resolution CAM models, which you use for severe weather, I'm not sure how they do with thermodynamic profiles with this kind of stuff, so I'm just looking at them. But just to show you there's a difference here. And there's a difference here, much warmer, 5-6 degrees Celsius. One down here. The GFS has a little pocket there, very small one though, from Oklahoma City down southwards, Chickasha, and down toward Lawton in Wichita Falls. And then there's the Canadian there as well. So just to kind of show you, not every model agrees on the temperature profile of where the warmest or coolest temperatures are going to be, and that makes it even more of a headache when you're trying to pinpoint the exact location. So I'm still going with the same area I've had before because I don't have a reason to change it until I can see another reason to change it. I just don't see a reason to change it yet. There's just too much variability in what I've seen. All right, so let's go to the Sunday dry slot period where the dry air comes in, mid-levels of the atmosphere, and it does shoot in here across central, southern, southeastern Oklahoma. What that does is it shuts down some of the heavy precipitation, which of course a lot of it's going to be the rain the first half of the day anyway. But on the northwest side of it here, this is going to be all cold enough for a rain-snow mixed and then all snow once you kind of get a little bit back into the cooler air. Now this is for Sunday afternoon, but the point is Oklahoma City is right here. So the dry air does come in and cuts us in half. The west side of town kind of stays in the moisture. The right side does get a little bit of a break there. So there might be a little bit more precipitation to the west as a result. Otherwise, in the evening, this big band right here, you can see the confluence zone, deformation zone, we call it, where we get a big increase in humidity along a very thin line. And I'm going to give you an idea what this looks like. So I'm going to pick a point, Piedmont, kind of for example. And I want to show you what it shows here. Temperature of 39 degrees. Yeah, that's too warm, isn't it? All right, and let me go down here and pick in the middle. Let's go El Reno. Let's see what El Reno says. All right, 37 degrees. Okay, and now let me go down here to like Tuttle and Minco, that area. 33 degrees. You see what I'm saying? It is a big difference just a few miles down the road each time. That is almost a 5 degree spread in temperatures just over about a 40-mile range from northeast to southwest. Actually about a 30-mile range, not even that much. And that is why this is fun, because we're looking at some really detailed data that we're trying to hyper local forecast. All right, so once you get to midnight though, look what happens. I'll just pick right in the middle of Oklahoma County, for example. 33 degrees. See, so it's just a timing thing. It's like the model eventually gets you there. It just, somebody will get there earlier than others. Closer to the upper low, you're there earlier. Further away, it takes it a while longer. So that was kind of the take home of that. If we look at the HRR and the wrap actually are the coldest when it comes to temperatures. By the way, for Saturday, let's see, where are we? Saturday afternoon, 50s, 40s. So another decent day. All right, there will be a little bit of rain around. But as we head into Sunday morning, this is where it's different. So the HRR thinks we don't really warm up because we have clouds all day and it's rainfall, which is fine. And we also have a little weak cold air advection because we are going to have a north to northeast wind bringing in just slightly cooler air. Not much, like a degree or two, along with lower dew points, just by a couple of degrees. So it's very weak cold air advection to offset any insulation that would try to warm things up. So it's going to go a little bit on the colder side. And as a result of that, it transitions us over to snowfall much sooner. So here's 10 o'clock, 11 o'clock, noontime. And really, it has this favored area from really Oklahoma City out to the west, cold enough to where this can all be snow for the first half of Sunday. That is an earlier transition than the other model, than the NAM. But the RAP and the HER, which is our short-term highest resolution ones, they love it. They're going cold. And therefore, they go lots of snow. So 3 and 4 o'clock, you can see what happens here. The cold air kind of shifts, sags a little bit down here to the south, starts to spread out to the east a little bit by the time we head to 6 o'clock. So that means more snow starts to now mix in and travel south and east. So if you're going to the Super Bowl, if you're in this part of the state, you might already have to be dealing with snow, especially the further west you go. This is a wild card here in Oklahoma City. Whether or not we'll have it by then, depending on which model you pick. We'll wrap this up in a minute and I'll see which one I like. But otherwise, east, it's just a cold rain until later in the evening during the game itself. All right, so let's take a look at the breakdown of this. We'll use the HER as our big picture rainfall and snowfall. All right, so green is rain. That moves into Texas for tomorrow morning. All right, does move into Oklahoma, southwest Oklahoma through lunchtime, and into southern and southeastern Oklahoma. Just very light stuff. Another little round comes in late afternoon. So might be some sprinkles here in Oklahoma City tomorrow evening for your outdoor activities on Saturday. There's that little light shower activity moving through. Otherwise, you see all the blue. That's all snow. Kansas, Colorado, New Mexico, northwestern Oklahoma. This is by Sunday morning. Big rain down south, Texas and southern Oklahoma. There's all that blue moving into the state. Don't worry, I'm going to get a close-up view of this to show you. But you can see how it does affect the panhandle of Texas and northwestern Texas, but not Dallas. You guys should be warm enough to where you're just going to get rain out of this deal. But there's a lot of snow there expanding, so let's take a look, see what that looks like here on a close-up view. All right, so let's just go to 2 o'clock Saturday. All right, here is 7 o'clock Saturday, just a little light showers and sprinkles. All right, here we go. So there's 3 o'clock in the morning. It already has snow over here in northwest Oklahoma, the northwestern third of the state, from Enid to Elk City. By 5 and 6 o'clock, you can see how that shadow moves off to the east a little bit more. So by daybreak, here on Sunday, it is trying to say, we're just trying to have a struggle to mix over between rain and snow here in Oklahoma City. So if I pick right here in the middle of this purple area for Oklahoma City, we've got 34 degrees over 33. So, in other words, that is right on the line of having snow. And the model is conflicted as in which way to go. So it paints the purple on there as a result. So it's saying we might have a situation where we go back and forth between rain and snow, or snowflakes mixed in with the rain for a few hours on Sunday morning before it eventually changes over. By 9 o'clock in the morning, if I pick the same area here in Oklahoma City, it's got us at 33 over 33. So dropped it by 1 degree Fahrenheit, and now it's all snow. All right, so that's how crazy this thing can be. All right, here's 10 o'clock in the morning. Snow from Tulsa now starting to enter down through Oklahoma City, down to Lawton and the western parts of the state, Elk City, Enid, Ponca City, Amarillo. Some heavy snow through the late morning hours. Now we're at lunchtime. Tulsa's struggling. It's back to rain, so it looks like you guys might kind of go back and forth a little bit, according to this model. 2 and 3 o'clock in the afternoon, still snowing. Oklahoma City, south and west, Lawton, Elk City. That's a lot of snow for a lot of hours. So when you see the snowfall map for this, you'll understand why. Oh my goodness, that is a ton of snow. And then it finally gets more snow in Tulsa in the evening hours at 6 o'clock. And of course, there's still more to go because the storm system has to move out of the state. So I will tell you, the HER and the RAP have just gone nuts with the snow. I'm going to start you with the RAP because I want you to see what it's doing, because it's got colder temperatures like the HER, and it's got 7, 8, 9, 10, 11 inches of snow. And that's on the after, I believe it was a little bit after melting. Let me just do the Kutra method. 22 inches of snow, 20 inches of snow. So earlier at noontime I mentioned how much rain we're going to get with this whole thing. And we're talking widespread 1 to 2 inches of rain along I-40 southward. And the problem is at just a roughly 10-to-1 ratio, if you convert half of that, so maybe there's 1 inch of rain and 1 inch of snow. 1 inch is rain, and you take the other inch, instead of it being rain, you multiply by 10 factor, so now you have a foot of snow. So that's how easy it is to get a foot of snow in this case, because we have so much moisture, so much rainfall, or moisture coming out of the sky. So that's why it's going up so high on these amounts, because out here it thinks it's pretty much all snow for the whole event. Hence, 20 to 2 feet of snow, right? 20 inches, 22 inches. So that's why it's going so high. So it's not like it's out to lunch. It's just saying there's enough cold air where it's not raindrops at all. It's all snowflakes. And therefore, at a 10-to-1 ratio, simplicity looking at it, you're getting 2 inches of rain, well, it really equals to 2 feet of snow. So that's the reason why it's going so nuts. But we know the ground temperatures are warm, and we know the air temperature is going to be struggling right around 32 to 34 degrees in this area. So that means there is offset, there is melting on both ends. So you'll never be able to measure this much, regardless of how much actually falls out of the sky. Anyway, so I wanted to show you the wrap just because that was pretty impressive change. Now let's go to the HER and get the latest data on this. And then I'm going to zoom in, by the way. This will only take you to Sunday evening, so it doesn't take you to Monday morning, by the way. Not even that first map I showed you. It's a short-term model, only goes out to 48 hours. But it's the same idea. 5, 6, 7, 8, 9, 10. So a little less than the wrap, but the same general look to it. So those two models are neck and neck. And if you go with the NAM, it's not that different, honestly. It still goes up around a foot of snow out here in the west, but the same look to it, right? The little nudge. The only difference is what happens here in Oklahoma City proper during that lunchtime period. Do we change over to all snow early, or does it stay rain until the evening? The NAM favors the evening transition, whereas these other two high-res models favors the morning to noon transition. That's a big difference. Okay, so let's take a zoom up of that. And by the way, here is the rainfall on that. I'm just going to zip through the models. Just kind of focus your attention here on, let's see, I-40 runs about like so. And here's 44 to Oklahoma, to Tulsa. So just look how most of them kind of keep it along and south of that boundaries. Icon went a little north. But everybody else is pretty much staying right along or south. But again, all these values are 1 to 2 inches. So that's a ton of precipitation. Okay, so I gotten those out of order, which is why I was like, where'd my rainfall map go? But there it is. I just didn't move it in the right spot. Okay, so if you do look at, and let me see if the new GFS has come in. It has. Okay, so we'll pick the new GFS through Monday morning. All right, and we'll see what the track position is. It's obviously gone a little bit more to the north. But look at this. It loves I-44 corridor, 6, 7 inches of snow from Tulsa down to Oklahoma City. Hot spot over a foot northwest of Lawton, Elk City. It's so funny, Elk City. You've gone from, depending on which model you have, you go from 22 inches down to 1.8 inches. I mean, it's so silly, but it's just the model trying to find out where that northern fringe is. And of course, each model has different physics, so it's going to put out different amounts of snow and also different melting strategies. But for the GFS to see this is pretty impressive because the last few runs, it's almost had nothing in the state. So it's obviously going, wait a minute, what was I thinking? The Icon model looks a lot like a GFS, real splotchy, still anchored on I-44, but on the northern side. It's the most northern model. And I don't want to buy it because I like the southern shift, so I'm not going to buy the northern shift. The NAM, right along the highways, all right, right on the interstates. And there's that higher mounts out here in Elk City. See that? 12 inches, Amarillo 20. So again, this jives with the prior forecast anyway. I'm not mad at this at all. Let's go to the high resolution NAM, and it just says, oh, there's really not going to be a whole lot of snow because it's going to be too warm. And so it just starts putting, raindrops everywhere and a lot less snow, except for out here. All right, and then the last one was the European. European, man, I'm so disappointed. It doesn't know what to do. One day it goes snow, the next day it goes rain, then it goes back to snow. And I'm just like, because these models struggle with a 1 degree temperature change at near surface level, and that's the issue, and that's why this is so challenging. If you do look at the European on the global runs, though, all these little areas is where the model thinks it didn't snow, so it has increased the no-go, the no snow. Its confidence has really dropped off in a lot of these members. And the ones that are left have cut the numbers in half. There were so many around here. There was like a foot the other day, and now it's got down to 2 inches on the average. So that's the European, so which is just having a really tough time of it. And if you look at some of its outputs here, zoom this in for you, can see where it's going to focus most of the snow. It's like on the easy call. Colorado, New Mexico, Texas Panhandle, some around Missouri and Arkansas, and almost nothing for the body of Oklahoma. Isn't that crazy? And this is the one that started this whole thing off on Sunday. It was the one that went nuts. Now here's the SREF, high resolution one. It has a little bit more of a northern track. I like the southern track better. I would shove this down south, but man, it's going a foot of snow out there in western Oklahoma. 8 inches up here in central Canadian. it was kind of like the Euro. It's just, it says, you know what snowstorm? What are you talking about, Willis? Just kind of show you the variability. If you do look at the, which one we're at, the SREF, yeah, high resolution short-term model here for Oklahoma City. Earlier it had 5 inches. Now it has an average of about 3 inches. So it's dropped a little bit on the average, but it's got some up here around 15 inches, but also has some down here around a dusting. A lot of variability. So the winter storm severity index, which shows you where your trouble spots is going to be, the moderate impact has increased because the model output keeps increasing when it comes to total snowfall. So that's down here across the southwestern quadrant of the state, but it does have a minor impact here in the central Oklahoma, and of course out here in the west. So if you're traveling, this is for roadways, that kind of deal. So bridges and overpasses, obviously, are the main issues usually. With warm ground temperatures, it will at some point overcome the heating from the ground while it's nice and heavy, but then once it lets up, the heat will overtake it. So it's kind of a mixed bag. Temperatures here in Oklahoma City, again, not too bad tomorrow, 50s. Otherwise, 30s looks like for most of our Sunday, and then Monday will not as cold in the morning. Miles are warming things up a little bit in the morning, so there had been upper 20s. Now there's more widespread low 30s, but still watch out for any ice on bridges and overpasses, that kind of deal. Anything that's frozen over, and then we kind of warm things up after that. I did want to show you. Let's see, was it this guy? Yeah, we'll show a couple of these. So I want to show you the. Oh yeah, because I was going to tell you why the wrap model is going so nuts for Oklahoma City. All right, so let's see. Let's get you here in the frame. Okay, so this is Sunday at 5 a.m. All right, in Oklahoma City. So this little line right here, this little line of mine, I'm gonna let it shine. Goes right up here. All right, so this is the 0 degree Celsius. So everything over here left the line. That means it's below freezing in the atmosphere. If it's to the right of the line, right over here, it means it's above freezing. And right down here at the surface where we live and breathe. Okay, so that you've got your tutorial down. So what we're going to watch for is this little thing to kind of jive to the left. So let's go forward in time. 6 o'clock, 7 o'clock, 8 o'clock. Okay, it's right on the line. 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. Oh, what just happened? We just jumped to the left of the line. So let me clear this. So you see, just left the line. That means the atmosphere is, or the column is now frozen all the way up, with the exception right here, we're at 0.8 degrees Celsius, almost 1 degree Celsius. So because of that, then the model says, all right, it's cold, Oklahoma City, it's noontime, and you're going to have all snow. And if you'll notice, we go every hour after that, it stays to the left of that line. Matter of fact, it gets colder in the column, much colder. All right, so this is a very cold model output. As a result, it puts down here counting these little bars of snow, and it gives us about 8 inches of snow here in Oklahoma City. And this is a ton of lift, ton of moisture. Everything else checks the boxes. So if the model is correct on the very low level temperature profile with the weak cold air advection coming in from Kansas, etc., it doesn't have too much of a cold bias, then there you go. You get an earlier transition by noon here in Oklahoma City for snowfall, and therefore you get more snow as a result because you'll be under that snow for a longer period of time. All right, now what about the NAM? The NAM had been leading the charge, right? And then I'm going to go show you the HER. You thought the wrap was something. All right, so the NAM, now it has a later transition over, like we talked about, late, like 6 o'clock onward. So therefore, its snow accumulation is only around 3 inches here in Oklahoma City. Otherwise, still got plenty of lift, still got all the moisture, so nothing's changed in the setup of the environment. And if I back this up, I'll show you. So remember, we're going to watch this little spot right in here. It's got to get left of this line, and then where it's going to transition over. So there's 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8, 9, 10, finally. So there's the NAM. It's late. This is a big. Now, part of this is because, if you remember, it was about a 6-hour late on the position from our prior runs. In other words, the model was too fast with it, so now it slowed it down. Hence, it slowed down the transition of this. That's the main reason for it. Anyway, there's 11 o'clock, midnight, onward, etc. And it's obviously plenty below freezing for the rest of that event. All right, let's go look at the HER. So the HER will start you off Sunday morning, 5 a.m. Very similar to the wrap. All right, so there's 35 hours out. Okay, here we go. 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 o'clock. All right, it's already now on the line, so it's going, you know what, let's start transitioning it to snow. There's 11 o'clock here, and then there's noon, and then it just stays below freezing for the whole time. And as a result, the HER then goes 13 inches of snow in Oklahoma City. 13 inches. Now, I'm going to do a max temp and profile because I think that's probably more reflective, because we're probably going to have, like I said, those numbers that'll be around 34, 35 degrees at some time, at least in this, even if it were to transition early. And with that, it drops the snowfall totals to a paltry 6.5 inches. So there you go. 6.5 inches on that one. If I went back to the wrap and also use that same max technique, it was only 6 inches as well. So that kind of dampers things when the model goes, oh, you want me to factor in that it's not at freezing and it's going to be more like that? Yeah, I do, because I want more realistic numbers. So that's 6 inches of snow, though. That's still impressive. So anyway, all right, so that's it. So that's all the data, everything to look at. Oh, no, hold up. Hold up. No, remember the GFS had just come in. I wanted to compare the upper level low position. That's what I was going to do. And then I'll tell you what my thoughts are. Okay, so let's just refresh this. All right, and we are at midnight, so let's go back to 7 p.m. All right, so the GFS is right here. And NAM was here. GFS was there. So the GFS was a little bit more to the east and south. All right, let's go to next 3 hours. NAM, GFS. The GFS is faster. So at 9 p.m. it has it pretty much centered right just southwest of Ardmore. Whereas the NAM still has it pretty much over Wichita Falls. So the GFS would have a quicker changeover as a result of that. All right, and let's go to midnight. There's the NAM, again centered roughly Paoli, Pauls Valley, something like that. And the GFS is down here to the south, hugging the Red River Valley. So Durant looks like the center there. So the GFS is a little bit more on the southern track than the NAM is. So what that just means, it just brings the heavier track, southward a little bit versus the NAM. If we should have the snowfall map updated. Let me see. I think we looked at that earlier. I think it was still pretty good though. Let's see. 6 a.m. Yeah, it was. It was still 7 inches here. So it's right along 44, and the NAM just a hair on the north side. So about a 30-mile difference between the two. But the take-home obviously is a better higher amounts southwest in both models, and then pockets of bursts elsewhere. All right, so there you go. Okay. So there's a lot of bust potential, I will say that. Anytime you're having to deal with the transition from rain to snow and you're hoping that the track of the upper level low is perfect, you're hoping that it closes off and strengthens and intensifies, where you get a lot of this transferring down of colder temperatures aloft dynamically through the snowfall into the surface to cool it down from, say, 36 to 35 to 34 to 33 degrees. Anytime you're wanting on that to verify and to create your snow situation, it's like this, man. It can go either way. So is dangerous. So if you have to hedge your bets, obviously. You've got to call for the event, which is the snow. And then if it turns out we stay at 36 degrees and it's a cold rain, then that's just the way it is. If it's 34 and you're shoveling it out there for all of 2 hours, well, then that's the way it is. But the good news is it'll melt quick regardless. Amounts, even though they may be excessive, if we could get a foot of snow to fall out of the sky, again, with the QPF around, that's not a problem, especially out western Oklahoma, southwest Oklahoma. But it will still offset because there will be some melting that happens both from ground level and just from the air temperatures themselves. So you will never be able to measure exactly what's coming out of the sky. You're going to maybe divide by half. There's really no rudimentary way to tell you what that end number is going to be, because it will continue to change. It's fluid and dynamic. So you just got there and measure it different times. But it'll be an evening event for central in northern eastern Oklahoma, because there's a changeover later, right? After around lunchtime here in central Oklahoma, give or take the models. If you want the early version or if you want the late version, you'll get more snow. But by the time we head into Monday morning, it's all over with, it's all gone, and then everything starts to melt pretty quickly. So obviously if it hits the big towns, the big communities, well, then yeah, maybe schools will close, but it's one of those deals where it's going to melt really fast on Monday itself, so there won't be a whole lot left over except for shaded areas. And then you just kind of watch those, refreezes, overnight in the morning hours on some elevated surfaces, etc. But it's a pretty good event. There's a lot of moisture in place, so the benefits here is obviously for drought conditions and getting the ground moist. So we do need that. We do take advantage of that during El Nino years, which is what we have currently underway. But as far as the snowfall total is concerned, highest amounts I-44 corridor, and then out west on I-40. Western, southwest Oklahoma has got the best potential for more widespread, larger amounts. Sure, upper digits on your fingers. Yeah, I can see that happening. Mid digits on your fingers, in central and parts of northeast Oklahoma. Yeah, I can see that happening as well. So that's kind of what I got going on for you. That's kind of a smooth, averaged out of the data with a little common sense. But again, you'll have to measure that and try to catch it at the right time. And it'll be wet snow. Kids will be able to play with it. Kids obviously in western parts of the state will get to play with it during the day. The kids out in northeastern Oklahoma will have to wait till the evening hours and push that mom and dad, I don't want to go to bed yet, clock to enjoy it. And that's it. So just be careful out there on your Super Bowl Sunday. I'll do another live update on a Saturday, probably around like 1 o'clock. That's when all the latest data will be finally coming in, and then really that'll be it. I mean, I really don't expect much changes at this point in time unless we get that 24-hour window and the models realize, everything's about 1 or 2 degrees too warm than what we thought it was, and then if that happens, this whole thing just goes up in smoke. However, if they say, no, it's exactly what we thought it would be, then it's game on. So there you go. That's what I got for you. Best I can do you. That's all the tools is through at you. Anyway, so now you can get a little idea of what goes on behind the scenes when a meteorologist has to forecast. This includes every meteorologist that has access to data and actually chooses to look at it, including the weather service guys, whatever, and they all sit around. And there's a lot of you can go back on your knowledge, you can go back on your experience historically, climatologically. You can throw in a lot of these little factors. Obviously there's tons of model guidance. Pick your model, you get your guidance out of it. Some's better than others given different circumstances and situations. And then you usually have like little old rules. And this isn't so much nowadays as it's 2024. But in the old days, when we didn't have all these fancy computer outputs, we only had 1 or 2, and it was archaic. You had to use a lot of rules of thumb to generate forecasts for this that were somewhat decent. And a lot of those rules have fallen by the wayside because they got replaced with better output from the models, but some of those still do apply in certain situations. But anyway, so those are still used probably by some old-time forecasters that kind of throw that in too. But otherwise, that's it, man. I kind of gave you just a general deal of what you can look at to kind of get an idea of what's going to happen. And the frustrating thing with snow is it's so variable, and no one is ever happy. Well, let's just say someone's happy, but most people are usually not happy, depending on which side of the fence you want to be on, feast or famine. And the kids, of course, are always going to want snow, and they're not going to be happy at all if all they get's a dusting or a few flurries. But unfortunately, it's not going to be a wide spread across the entire state deal. It's going to be on a narrow corridor deal for the really good measurable snow, the way this is looking. But hey, still looks like a pretty good snowstorm, and it's for Super Bowl Sunday, so what more do you want? All right, that's it for me. Thanks again for watching tonight, all the stars, all the support you have that you showed over the last few weeks and months and years. Appreciate you immensely. And Tim, long range, please. I'm like, are you kidding me, man? You know how much energy and time it takes to try to weed through all this nonsense? I ain't got no time for long range. I can tell you in my blog, I had mentioned we're still going to be in a cold pattern for the second half, I think February, with off and on precipitation, which could mean another round or two of some monkey business when it comes to weather, winter weather, but I ain't got time for that, so we'll deal with that later. Let's get through Sunday first. All right, there, Haas. All right, I'm out of here. You guys have a great night, good weekend. Some of you I'll see tomorrow. Some of you I might see Sunday. Some of you I might not see at all. Enjoy the weather. Take care.